All right, class, let's continue graphing trig functions, and I picked a cosine this time. So remember, when you graph a cosine wave, that's its shape, right? Starting at 0, back, when x is 0, right, it starts at 1, back at 1, right, when x is 2 pi. Okay, so that's the shape we'll pick. So there it is. Let's see what kind of transformations we might have. Now, what does the negative really 1 due to the cosine function? So I'm multiplying all the cosine values, all the y values by a negative. That simply means a reflection about the x-axis, right? So all the y values I've had before that were positive are now negative, and backwards the ones that are negative are now positive. So it's a reflection about the x-axis. Okay. What do I have here? This 2 value that's multiplied to x, that simply means I have to take all the x values and divide them by 2, right? So what this messes with is the period. So divide, or I should say it's a horizontal compression by a factor of 2. And finally, the last thing right here, from all the x values, I am minusing pi over 2. So that simply means I'm going to take all the x values and add pi over 2 to it. So what that does, it's a horizontal shift to the right, pi over 2 units. Okay, so what does that simply mean? The amplitude is still a 1. Why? Because again, even if I flip it, it's still going to be 1 unit going up and 1 unit coming down, right? Distance from the midline to the highest point or to the lowest point. Horizontal compression, that messes with the period. So your 2 pi period gets cut in half. So now the period's just going to be pi. And then I have a horizontal shift pi over 2 units to the right. What that does is messes with my phase shift. So instead of starting at 0, I'm now starting at pi over 2. So we went pi over 2 units to the right. And by the way, there is no vertical shift, okay, or it stays at 0. So in other words, midline is still y equals to 0. Okay, all right, so that being said, let's try and graph this. So I'm going to go as high as 1, as low as -1. The midline around what? Y equals to 0, right? So the midline still y equals to 0. Okay. The period is pi, but I'm starting at pi over 2. So really, that simply means I'm starting at a pi over 2, and I'm going to go pi units further to 3 pi over 2. So again, 1 pi over 2, 2 pi over 2, which is pi, and then that's 3 pi over 2. So I'm keeping my spacing very much consistent. So I already knew if I picked this to be a half a pi, another half a pi, another half a pi, right? So that's a pi over 2 distance. And that's it. So the graph is going to start right here. What does a graph of cosine really look like? I'm just going to draw a regular cosine for you. It starts at 1, cut this into 4 equal parts, goes to 0, down to -1, back up at 0, back up at 1, right? That's a cosine wave right here. However, why didn't I graph it right away, or why didn't I draw it solidly? Because of this -1 that tells me I have to reflect it about the x-axis. So instead of making it go down and back up, I have to start it backwards. Go up and back down. So that's one complete flipped wave. And I need to also label these. So halfway between, by the way, that's a 2 pi over 2. So really, how do I find half points? I add them up and divide by 2. Ta-da. Add them up, divide by 2. So I like to add fractions with common denominators. That's why I wrote this back as a 2 pi over 2. So when I add these up, I get 3 pi over 2. Cut it in half. That's a 3 pi over 4. add these and divide by 2, so that's a 5 pi over 2 cut in half. That's a 5 pi over 4. Now, of course, you can take your calculators and do the same thing. Make sure you put the answers, though, in fractions. So don't write 1.25 pi or 0.75 pi, right? Leave it as a fraction. And again, this is just one complete cycle. If we need more, what do we do with this? Right? Keep on going, right? The same exact width and the same exact height, on and on. So again, the other trick that I showed you up here, if you're not so sure where to start and where to end it, easy. Take the whole thing that's inside the cosine, which is your what? So that's another way. Of course, your phase shift is always the starting point, by the way. And to figure out the end point, you just add the period to it, right? So if it started pi over 2 or a half, and you have to go 1 pi, so 1. So 1 plus a half is 1 1/2, which is 3/2, right? So that's the length of it. You start at a half and you go 1 more pi. Well, that's 3 pi over 2. But here it is, in case you are wondering. A regular cosine goes from 0 to 2 pi. Yes, so all I have to do is solve this for x. So the first thing I'm going to do is divide by 2. Remember, what does the dividing by 2 do? It's very nicely, you see it right here, in fact. What does the dividing by 2 do? It changes your period, right? So now, instead of going from 0 to 2 pi, you go from 0 to pi. Then, what else do I have to do to solve for x? Which, again, is also why you see transformations with x are always, what do you have to do in order to get to x? So it's always the opposite. So you start at pi over 2, and you end at 1 plus a half, again, is 3/2. So that's your start, and that's your end point, okay? Just like we did. So it's really nice either way. It shows you really the transformations that must occur to x. You know where you start, you know where you end, and you cut that interval into 4 equal parts for the 4 quadrants you have to go through, right? Okay, so let's summarize all of this. And as you see, in general, we have some what? Numbers multiplied to the sine or cosine function, it doesn't matter. Some values multiplied to x, added or subtracted from x, and then some value added or subtracted to your sine function. So each of these has a role, right? A, or I should say the absolute value of A, is the amplitude. And what I mean by the absolute value, the last example we had a -1 up front, yet the amplitude still was a positive one, right? Because the amplitude's a distance, so it doesn't matter in what direction you're going. Okay, so the absolute value of A, make it positive. The amplitude should always be a positive number. B is what messes with your period. So the period is regularly 2 pi, but you divide by this B value, whatever it might be, right? Doesn't always have to be a number more than 1. It could be a number less than 1. Then what? The C value is your phase shift. So your phase shift is the C units, right, to the right. Again, if it's minusing a value, you go C to the right, right? If you're adding something, that means you subtract the negative, right? So whatever subtracted from x, that's how many units you're going left or right. And then D is your vertical shift. Up or down. Depends, again, here, right, left, or right. Depends on, again, positive or negative. Okay, so let's put all this to good use. And here is a function that's got it all. Okay, so the 1/2 in the front of it has to do with the amplitude. So the amplitude of this is going to be just 1/2 unit, right, from the midline. Okay, this is where you have to be super careful, because in this formula, as you see, the B is factored out, and here it's inside. So every time, let me bring back the example we just did. See how this 2 is factored out up front, right? So the question is, what is the phase shift? It turns out the phase shift is what's added or subtracted from x, not from 2x or 5x or 1/2 x, from x. So the best thing to do, and again, it's the same when you graph any function whatsoever. If something's multiplied to x and added or subtracted, it's always good to factor that out. So I'm going to factor this out. So when you factor out something, you are dividing, right? You're dividing it out. So 2x divided by 2 is 1, and pi over 3 divided by 2 is pi over 6. So of course, when you multiply these back out, you get your pi over 3, okay? So that makes it easier. What is the period? The period is 2 pi divided by whatever's multiplied to x, which is the same too. What's the phase shift? The phase shift, in fact, is pi over 6, right? That's what's subtracted from x. So in other words, positive pi over 6. So in other words, you're going right. Yes, pi over 6 units. And is there a vertical shift? Sure enough, it's -1. So in other words, y equals to -1 is your midline. Okay, so let's graph this. So I'm going to start my graph at pi over 6. How far do I go? 1 full pi. So now be careful. I'm going to go by pi over 6's. So if this is a pi over 6, that's 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. That's 1 and 1/6 pi. So again, the period is pi, so it has to be exactly 1 long. And I am keeping this very consistent, and I need you to do the same, right? So in other words, I cannot make what? If this is pi over 6, then I'm going to pick pi here. I don't think so. If that's 1/6, this is not 1, because it's now 1/6. If this is 1, then definitely this is not 1/6 only, right? It looks more like maybe a quarter or even a third. Yes. So be very careful with your spacings. Okay. All right. What happens with this graph? It's going to have a vertical shift of 1 unit. Okay, it's 1 unit down. So I'm going to go 1 unit down. So if I pick this to be my -1, I'm going to take this graph 1 unit down off the midline. So in other words, it's going to be centered along this line, yes. Okay, and then what's the amplitude? A half. So I'm going to go half up and half a unit down from here. -1/2 and -1.5, right? Or -3/2. It's up to you. Good. So I'm going to bounce up and down between these. So I need the half mark point. Add them up. So that's 8 pi over 6 divided by 2. That's 4 pi over 6. And of course, that's 2 pi over 3. But I'm just going to keep it easier. Then add these up and divide it in half, which is here. 5 pi over 6 divided by 2 is 5 pi over 12. And then the halfway mark between these two, add them up, divide by 2. So 11 pi over 6 divided by 2 is 11 pi over 12. Okay, so let's draw this. What is it? It's a cosine. Be careful what you're drawing. So what does the cosine do? At the beginning point, it starts at the top. A quarter of the way goes down to the center. Another quarter of the way goes down to the lowest point, back up at the center, at the end point, back up at the top. Now again, make sure you're not making a V, but you're making a rounded off thing. Perfect, there it is. So right here, centered around -1. If I need it to keep on going, that's what the graph will look like. And then all you have to do is keep adding these units, right? So another pi to the next one, which is 13 pi. By the way, that would be 13 pi over 6, right? One more pi after that. And the same thing keeps on going. It's actually going to be here, not at 0. So on and so on. So there it is. Okay. That's the graph. And again, I'm going to show you, you don't need to do both, but if it's hard for you to figure out, again, the beginning point and the end point, what was our trick? And again, that also helps with the period and everything. You take what's inside the cosine, which this is the whole thing inside the cosine. And a cosine does normally go between what? 0 and 2 pi. Yes. So now you solve this double inequality for x. What do you do first? Add pi over 3. So that's 1 pi over 3, 2x. And that's 2 plus a third, that's 7/3. Yeah. And then divide by 2, and again, to divide by 2, since these are fractions, I'm just going to multiply by a half. Okay, looks better than pi over 3 over 1/2. Or over 2. So that's a pi over 6. And that's a 7 pi over 6. So that's where your x should go to. Starting point, end point. As you see, starting point, end point, perfectly. Okay. All right, so there it is. Maybe one more? Anything. Let's just try one more. What about a -2 sine of, how about 3x minus or plus pi? Let's just try this. So not crazy about vertical shifts. We don't quite need that every single time. But here it is. So let's find the amplitude. What is the amplitude? The absolute value of -2, which is 2. So it's going to go 2 units up. It's a vertical stretch. What is the period? The period is what is 2 pi divided by what's multiplied to x. What's the phase shift? Be careful. The phase shift's not -pi. So what do I have to do? I have to factor out this 3, by the way. And if I do so, that's a pi over 3, divide by 3. So as you see, the phase shift is -pi over 3. What does it mean? Why negative? Because that's what's subtracted from x, right? It's the opposite of this value. So I'm not going to the right. I'm in fact going to go to the left. Is there a vertical shift? No. Okay. So, that's pretty easy. This is what I mean. I'm going to start at a -pi over 3. So you pick your units, whatever. And I have to go what? That's nice that it's the same. That's why I meant it's easy, because I'm going with the same denominator. So if this is a pi over 3, then this is 2 pi over 3's to the right. Okay? So that's a 2 pi over 3 distance, yes, for the whole period. So all I have to do is cut this in half, which is at 0. Half and half, so -pi over 6, positive pi over 6. And then what else? I have to pick the height. So the amplitude is 2. So as high as 2 and as low as -2, right? And there you have it. Again, it could have been a 1, it could have been a 2 pi. Labeling is everything. And now what do I draw in between? I draw a flipped sign. What do I mean by a flipped sign? Well, a normal sign would start at 0, go up, come down, go up, come down, right? That's the shape of a sign. Except for when I flip it, start at 0, first goes down, then back up, then down. Okay, there you have it. So what if the problem would have said just graph over and over and over again? Not just one complete cycle, but over and over again. Okay, fine. Let's keep on going. If that's a pi over 3, that's 2 pi over 3, and that's 3 pi over 3. So, right, I need 2 of these pi over 3's for another cycle. So, there you go. You don't need all the labelings in between, but just a little bit. So, there you go. What else do I need? I don't quite have the room, but just pick another one just like it, right? So, another pi over 3, which is 4 pi over 3. And so on and so on. So we can do the same thing going left. 1, over 3. That's negative 2 pi over 3. And that's negative 3 pi over 3. So in other words, negative pi. Okay, so what do I do between these 2 pi units? I'm drawing another one of these cycles. There you go. And you just keep on going. The spacing is important, right? Because it also helps you count, right? 1 pi over 2, 2 pi over 3, 3 pi over 3, 4 pi over 3. And then you just copy and paste it, right? And there is your graph. So that's section 6.1.